So hello guys, today we are going to do a little question that goes by the name maximum depth of binary tree. It's an easy level question. The question number is 104. Okay. So let us start by first reading the problem statement. What does the problem say? Okay. So you are given the root of the binary tree, return its maximum depth. Okay. So you are just given a root of the binary tree and you have to return the maximum depth of the binary tree. Okay. But what is the meaning of depth? Binary tree's maximum depth is the number of nodes along the longest path from root node down to the farthest leaf node. Okay, seems nice, but what is the meaning of it? Okay, let us see by an example. Okay, suppose this is your binary tree. This is your binary tree. 1, 2, 3, and 4. Okay, and this is my root node. This is my root node. So it is saying that the maximum distance. Basically, depth of the binary tree is given by we consider the same level nodes as level 1. This is the level 1, this is level 2, this is level 3. Okay. This is level 3. So if here comes one more node, then this is level 4. Okay, but we are not considering it for now. Not considering it. Okay, I hope you got the concept. What is behind? What we are doing? Okay, so it is saying that maximum distance from the root node. This is the root node to the farthest leaf node. That is leaf node that has the maximum level. That is this. This. Okay. So this is the farthest leaf node. How the farthest leaf node? Farthest leaf node because it has the highest level. It is at the maximum depth. It is at the maximum depth. Okay. So these both are on level 2 and this is the only one that is on level 3. Level 3. So if I tell you in some terms, basically you have to find the distance level n node to level 1 node. This distance you have to find. Level n node to level 1 node. Okay, this is the distance that you want to find. Okay, and what will be the distance in this case? Basically, if I start traversing from the first node, this is the first branch that I come across. So 1, and this is the second branch that I come across. So 2. So 2 is my answer in this case. 2 is my answer in this case. That will be my maximum depth, max depth. If I consider any other path, if I consider any other depth, suppose this, so it is only having one branch in between, only having one branch in between. So 2 is obviously greater than 1. So this is not my answer. This is not my answer. Okay. So, so for this case, if I see there is a root node, there is a root node that would independent be a level, and all the other nodes that are coming would also form a level, Suppose this is level, this is level 1, this is level 2, any other node, this is level 3, any other node, then level 4. Okay, then level 4. So each of these branch would constitute a level, So if I am coming onto the diff, this would return me 1, this would return me 1, this would return me 2, this would return me 3, and 3 plus 1 for this level plus 1 for this level. So 3 plus 1 equal to 4. 3 plus 1 equal to 4. Okay. If I consider like this, that this is my root node, this is my root node, and there are two of my subtrees. There are two of my subtrees. Be it be the right subtree, and this is the left subtree. This is the left subtree. Okay, right subtree and left subtree. Okay, this must be having some levels. This must be having some levels. Some levels. Say it be RL, and this must be having some levels. Say it be LL. Okay, this is the leaf node, and every time you go on to another node, would add 1. It would add 1. Why? Why? Because the node is adding itself. Because the node is adding itself. Okay. And the maximum height of the left and the right would give me the answer. Would give me the answer. Okay. Suppose basically if three nodes are present, 0, 1, 2. Basically if three nodes are not present, two nodes are present. Okay. So what would be my answer in this case? First level, so 1 plus maximum of left comma right, maximum of left comma right. Basically this left, if it is existing, so it would add in this, so it would be maximum of 1 comma 0. As there is no node here, so it would be contributing 0. It would be contributing 0. So if there is no root means no level, and no level means it would be contributing 0. And if there is a level, if there is a root, if there is a root, okay, just see its left and right. Just see its left and right. If you traverse its left and right, okay, you just have to return max of left comma right for each case. 1 plus max of left comma right for each case. Why plus 1? Because this plus 1 is for the current node from where you are traversing. Current node from where you are traversing, because that node would also be a level. That node would also be a level. Okay. So basically, if I do a try run of the SGS that is given 3, 9, 20, 15, 17, 3, 9, 20, 15, 17, 7, 20, 15, 7. Okay, I'm preserving this level for future use. For future use. Okay, so this plus one is mandatory. This plus one is mandatory. Why? Because root node is existing. It is consisting of one level. 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 So I'll just pass on my left and the right subtree to the function. Left and right subtree to the function. I'll say that find me the maximum levels in the left and right subtree recursively. What does it mean by recursively? Suppose my function is like this, h of root. My code would be something like this. If there it doesn't exist any root, I'll simply return 0. Okay. Else any other case, I'll simply return 1 plus y1 because including the current node, and maximum of the left and the right. Maximum of left and the right. Okay, so 1 plus maximum of left comma h of right. Why h of left and h of right? Because this will be done recursively and this would be done recursively. Okay, h of left will be acting as a subtree. So this function would be performed recursively. Recursive means again and again, and this function would be performing recursively for the right subtree as well. Okay, and it would return me the maximum. It would return me the maximum answer. It would return me the maximum answer. Okay. Now considering coming back to my test case, 10, 5, 20, 15, then 7. Okay. Suppose this is my test case. Okay. And what I'll consider is I'll consider this alone for the last plus one that we have to do. This is my left subtree that is consisting of only 55. This is my right subtree that is consisting of 20, 15 and 7. 20, 15 and 7. Okay. So for this single node, okay, what this would be consisting of a level. This would be consisting of a level. So one would be added. I'll traverse the left subtree, but I find nothing here. I'll simply return 0. If I traverse the right subtree, I'll find nothing here. I'll simply return 0. Okay, so 1 plus maximum of left comma right, but as this is 0, 1 would be returned. So here 1 is returned. Okay, from left subtree 1 is returned. If I come to the right subtree, 20, 15 and 7, this is 20, 15 and 7. Okay, suppose consider this as plus 1 because this would also constitute a level. I'll come to the left subtree, I'll come to the right subtree, I'll again split them. This plus 1 is mandatory, okay, because this is also adding up to a level. This node is also adding up to a level. Okay, so I have to do this plus 3, plus 1. I'll split them again, one node would be 15 and one node would be 7. Okay, this would be consisting of node because this would be consisting of level, so I'll add plus 1. This would be consisting of level, so I'll add plus 1. I'll come to the left, I'll find nothing, I'll return. I'll come to the right, I'll find nothing, I'll return. Okay, so 1 is returned for this case. For 15, 1 is returned. For 7, if I come to the left, nothing is found, I'll return 0. I'll come to the right, nothing is found, I'll return 0. For 7, also 1 is returned. For 7 and 15, both 1 is returned. So 1 plus maximum of 1 comma 1, 1 plus maximum of 1 comma 1, so 1 plus 1 is equal to 2. So my right subtree, if I see, my right subtree is able to return me 2 and my left subtree is able to return me 1. So if I add to my final answer, that is 1 plus max of 1 comma 2, so it would be 1 plus 2, it would be 3, it would be 3. That is my final answer. That is my final answer. Okay, that is my final answer. Okay, so if I try to write the code for this, okay, if there is no root, I'll simply return 0. Else, what I'll do is I'll add 1 for the current node. And what I want is I want the height of the left subtree. I want the depth of the left subtree as well as I want the depth of the right subtree. Okay, if I try to run it, so this call would do it again and again recursively. Okay, if I try to submit, so it is submitted. Okay, so this call would be doing the thing recursively. Okay, what I'm doing is, if I try to summarize, if there is no root, I'll simply return 0. And if there is a root, this root will be consisting of one level, and I will be considering max of left subtree comma the right subtree. So I'll have to perform the same function again and again. Okay, if I try for my second test case, that is 1 null and 2. If I try to see what they're trying to say by this, 1 null and 2, so 1 2, so 1 and 2. Okay, basically for the root, plus 1 is reserved, and I'll see the max depth of the left and the right subtree. So for the left subtree, my maximum height is 0 as it is returned. Okay, and this would also consist of a level. So 1 plus maximum of 0 comma 0, 1 is returned from this. Okay, so 1 plus maximum of 0 comma 1, 1 plus 1 equal to 2. So 2 is returned in this case. As you can see, 2 is returned. Okay, so there it is very easy. Here I found no root, so this case ran. Okay, and for this node there is a node, so this line ran. This line ran. As there is a node, I traverse to left subtree and right subtree. Okay, so this was my code. The code looks like only 2 lines. The code is only 2 lines, but it is running recursively. You have to understand recursion to know how it is working in depth. If you don't know recursion, don't worry, I'll be making a playlist on recursion soon. Okay, but if you do new recursion and you understood this question, or if you have any doubts, just ping it down in the comments. If you like the solution, like, share, and subscribe. Thank you. Have a nice day. Bye bye.